Dear Madam President, this is all you need to know about radiation and death. Now, the amount of damage dealt to your cells is measured in REMs, and to get a sense of how big one REM is, picture 2 billion gamma rays going through your body. That seems like a lot, but really, one gamma ray only emits enough energy to increase your body's temperature by 1/1000th of a degree Celsius. And if you were to get a whole body dose of radiation for 1 REM, that means that each gram of your body received 1 REM of radiation. Now let's take a look at this chart. Anything above 100 REMs is what we call radiation poisoning, and at the 200 to 300 range, you may feel nauseous, you may lose some hair, and you'll have an energy loss. At 300 plus is what we call LD 50, standing for a lethal dose with a 50% chance of death if left untreated. And in the 1,000 plus range, your survival, unfortunately, is unlikely. That's it.
Madam President, there's an arising crisis in terrorism. They are attempting to create a simple nuclear bomb that could cause more damage than the tragedy of 2001. There are two types of bombs they could use. A uranium bomb, which needs purified uranium-235. This requires $1 billion of research and development. This is very fragile and can be easily destroyed unless well hidden. Next, a plutonium bomb. They would have to master the art of implosion, which is a very hard, intensive, and expensive process. I doubt that terrorist groups are able to master either of these two, but they are. It is possible that they have a missing USSR bomb. One of the major crises of a large nuclear explosion is the fallout. Strontium-90, a highly radioactive material, gets into the food supply and can easily kill you in as quickly as 1 year. 1 kiloton is a very small amount and is close to the nuclear test in 2006 in North Korea. 20 kilotons is like the bombs we used in World War II, and 1 megaton is a bomb that could be carried in a B-52 carrier.
Good morning, Madam President. Today I'm going to explain the uses and construction of radioisotope thermal generators, also known as RTGs. RTGs are made up of two main components: thermoelectric generators, which are made of different wire coils coupled together to produce energy from heat, and a radioactive sample. The samples are usually plutonium, atomic number 94. The radioactive sample creates heat, and the generator then takes this heat and transforms it into electrical power. Because of their long life and constant emission of an average level of power, RTGs are often used in deep space satellites, like the New Horizons satellite, which is going to reach the outer limits of the solar system within a couple of years. The plutonium used in RTGs is often bought directly from Russia because we can't produce it ourselves, which can sometimes lead to political conflicts and conflict of interest in political dealings with Russia. That's all.
Madam President, I'm going to tell you all that you need to know about the linear hypothesis, aka the linear no-threshold theory. The linear hypothesis tells you how much radiation is safe for a large area. For example, if you have 2,000 REM of radiation in a large area, the linear hypothesis states that if you have 2,500 people in that area, then although each person would only get 1 REM of radiation, and that is not likely to produce cancer, one person out of those 2,500 people is still likely to get cancer. The counter to this is the threshold theory. The threshold theory states that a person's body is strong enough to fight off the 1 REM of cancer that they will get.
Thank you. Madam President, this is what you need to know about thermonuclear weapons and controlled fusion for the purpose of generating power. Surprisingly, these two technologies are similar. The only difference is the fuel source. The basic principle of thermonuclear weapons is using uranium or plutonium to heat hydrogen atoms with contrasting charges until they no longer repel each other. In theory, it is possible to harness the energy emitted between hydrogen atoms without the explosion. This energy source could require very little fuel, only 100 kilograms of hydrogen, but produce massive amount of energy, thus making it the most efficient source of energy today. The problem is, we can't get it to stop exploding when we try to harness the energy.
Madam President, this is what you need to know about gas centrifuge uranium enrichment. While it's pretty hard to detect these plants or like buildings that have them, that have the centrifuges in them, they are still a risk because they can, over a year, like the size of a large lecture hall, can produce enough uranium to have several nuclear bombs. So like the centrifuges aren't that big. They're like not huge, like the size of the room. Like hundreds could fit into like the size of the two of these classrooms, and that's what they use. They're pretty hard to detect, like I said before, like using satellites right now to detect them. But so before, uranium is added with fluorine. Uranium-235 is added with fluorine, is put into centrifuges. The centrifuges spin at high rates, and slightly the uranium-238 is slightly heavier than uranium-235 because they're both different isotopes of uranium. So uranium-238 will separate to the outside as it's spinning, and because it's slightly heavier, and then the uranium-235 will stay more on the inside. So the 238 will be pumped out to a container that holds it, and then the uranium-235 will then go to another centrifuge and spin again. And it'll keep going through the processes until you get pretty much all the uranium-238 out. And the centrifuges are made of the Maranging steel, which is like pretty uncommon because the only things that use it are these centrifuges and some golf clubs, like high performance golf clubs. So that's like one way we tell if they're trying to use these centrifuges for uranium enrichment, because you're not going to be importing all this stuff unless you're using it for that or golf clubs.
Madam President, this is what you need to know about the 3 Mile Island. The worst nuclear accident to occur in the U.S. was 3 Mile Island. It happened in Harrisburg, Pennsylvania in 1979. The pumps of cooling water to the reactor failed, and a backup pump with a critical valve was closed, and also safety systems failed, so 1/3 of the core melted. But it did not melt through the steel vessel, so the Chinese syndrome did not happen. The Chinese syndrome is when it melts through the steel vessel and then melts to the ground and it goes to China. To make that clear, that did not happen. After the scientists, to prevent the buildup, leaked some of the radioactivity into the outside environment. And this happened right after the Chinese syndrome movie was created. So many people thought the accident was as worse as what was reenacted in the movie. They also started to freak out because the radioactivity in the region was 30% above the nation's average. But the scientists figured out that long before the accident, the radioactivity was always high in that region.
Madam President, this is all you need to know about nuclear waste. Nuclear wastes aren't as hazardous or as hard to manage as other toxic industrial wastes, such as the waste produced by fossil fuels. And the amount of radioactive waste is also very small compared to the amount of waste produced by fossil fuels. Basically, to dispose of radioactive waste, you drill a hole 1,000 meters deep, and you make these caverns and you fill it up with all the nuclear waste. And this would generally be in a more unpopulated area. You can also bury the waste in the ocean floor in an abyss, and the current is weak enough there that the waste won't be carried back to the shore for 140 years. But this hasn't been done yet because it would require an amendment of the law of the sea, but it would be safer than burying them in the Earth's crust.